In this question, we are interested in finding the area of the shaded region bounded between these two functions. So the top function, as you can see, is, let me change the color, is x squared plus 3, and the smaller y value is y equals to x. So how do we calculate this area? To calculate the area, we need definite integral. We know that a, or the area, is the definite integral of a to b, the larger y value minus the smaller y value with respect to x. Sometimes we can switch around as well, but for these two functions, we don't have that much of an issue. So basically the area is equal to the integral. Please note that here you have the starting point and the ending point. Your a is -1 and your b is 1. So far we know that this is -1 to 1. But the object is not symmetric. Just be careful here, everyone. The object that you have is not of symmetric shape. F of x is x squared plus 3, and g of x is x. Then you take the integral with respect to x. So the area is equal to, here you have x cubed divided by 3 plus 3x minus x squared over 2. X ranges between -1 to 1. So let us plug in 1, and then -1, a third, plus 3 minus a half, minus negative a third, minus 3 minus a half. So you basically have a third. Try my best to see if I can simplify anything eventually. Hopefully we get some opposite terms. Otherwise, you have to do a lot of algebra. Here, as you can see, a half and negative a half, they disappear. So you get 2/3 plus 6, or 20, divided by 3. So the area, since the question asked about the area, we look for the area, and it must be a positive value. So the area between these two functions is equal to 20 divided by 3. Whatever the unit is, you're going to square that unit. So your next question is, find the area bounded between the parabola and line. As we learn, the area is definite integral a to b of the larger y value minus the smaller y value with respect to x. But again, if it's difficult to take the integral with respect to x, we're going to switch these around. So the starting point and the ending point, they are both given to us. One of them is 0 and the other one is 6. If this 6 wasn't given to us, you needed to set x squared minus 4x equals to 2x and solve it. So let me show you. X squared minus 4x is equal to 2x. or x squared minus 4x minus 2x is equal to 0, or x squared minus 6x is equal to 0. If you factor out x, you get x minus 6 equal to 0. So x is 0, as you can see just right here. And the other x is 6, just right here. So again, if it's not given in the question to you, you have to solve using algebra. Very good. So the area is equal to the integral 0 to 6. The top function is now a line, right? The larger y value is 2x. So you're going to write down 2x, then minus the smaller y value, which is down here, or you have a ceiling, which is parenthesis x squared minus 4x. Then you take the integral with respect to x. So the area is equal to definite integral 0 to 6 of 2x minus x squared plus 4x dx, which in turn is equal to definite integral 0 to 6 of 6x minus x squared dx, and it's equal to 3x minus x cubed divided by 3. X ranges between 0 to 6. Well, plugging 0 doesn't help us because the term vanishes. What are we going to do? We're going to just plug in 6. You get 3 times 6 minus 6 cubed divided by 3, which is equal to, let's see, we can simplify this as much as we can, minus, let's see. So you have 2 times 36, but the value must be positive, right? Oh, I forgot to add exponent 2 here, right? Yeah. So this should be exponent 2. So let's raise it to the second power. So you get 36. Perfect. Let me just write it down here to make it a little bit. Make the calculation a little bit easier. Okay, let's see. So if I factor out 6 to the second power, I get 3 minus 2, or basically I have my 36. Okay, one small mistake, make the calculation wrong. Perfect. So you have your area, which is 36.